Great, this is section 6.3. We're going to use the method of cylindrical shells for setting these up. For this helpful video, I'm just going to be setting them up for you and letting you take the integrals, because I think that's the more difficult part when you're getting into some of these. The biggest thing about cylindrical shells, remember we're making these cylinders of a certain thin cardboard-like thickness. And so when we are modeling our shapes, we are going to make our representative rectangles parallel to our axis of rotation. And that will be very helpful for making sure we pick the right direction. All right, so let's look at number 3 here. And so we have y equals the cube root of x. So that looks something like this, right? We have y equals 0, which is the x-axis, goes right through there, and x equals 1. So this right here is actually your x-axis, and this is the line x equals 1. So here's the area contained by those. That's the first thing to look for. Where's the area contained? Now we're going to rotate about the y-axis. And so I want my rectangles to be vertical. When I do that, I see the short side is in the x direction, so that it will be a dx. Now remember, for all of these methods, what's the surface area of this? Well, the surface area is that 2 pi r. When I'm rotating about the x-axis, or about the y-axis, r is the same as the x value that we will rotate it. And then there is the height, let's call it the height of this, and then we always multiply by its thickness, dx, to get the volume of that cylindrical shell. And then we add them all up for all the x's. That's the integral. So we have then, putting in here, a 2 pi x. And then the height of this rectangle, notice y equals 0 is really nice, so the 0 down there, so we just have to take the upper value of the cube root of x, so I'm going to write that as x to the 1/3 dx, and we're going to go, the lesser value is 0, and the upper value is x equals 1. So there you go. So if you're going to integrate that, just stick them together, 4/3 dx. And you are a golden child, all right? That's great. All right, let's scooch this where we want it to be. There's number 3 for you. All right, number 4. Very similar. Let's sketch these things in here. So we have y equals x cubed. So that looks like this. Y equals 0. That's the x-axis. X equals 1. And x equals 2. All right. There's your y-axis there. So we're talking about this bounded region. Again, our typical rectangle would be vertical. We'd have a dx. And so we look at, well, what are our bounds of x? X goes from 1 to 2. That was pretty much given. Because y is 0, the height of every one of those rectangles is just x cubed. And remember, we need that 2 pi x stuck in there. This will be the volume of a stereotypical cylindrical shell. And you add them all up for x goes from 1 to 2. So the next part for you is to take that integral and evaluate. All right, let's look at number 5 here. Similarly, y equals e to the negative x squared. We just got to get a helpful picture on this, right? So e to the negative x squared, that isn't always a positive number, and as x increases, that decreases. So it looks something like this. Oh, except for this particular value is that because the x squared there, it's actually symmetric. So it'll look something more like this, let's say, okay? Something like that. Now it goes from y equals 0, x equals 0, x equals 1. So we're just talking about this box area. If I got my squiggle wrong, as long as it's in the right area, recognizing it's always positive, my picture here will be set. So we're still going about the y-axis, so we're going to use a dx here. We're going from x equals 0 to 1. We're going to have a 2 pi x, and then our height is e to the negative x squared. I will do a little bit with this one. So this one, the reason that they gave us that gnarly function is that it recognizes u substitution is now set up. If I let u be oops, I'll just say u is, we just let it be negative x squared or whatnot, then du would be, negative 2x dx. So it's pretty set up over here if we're going to do e to the u. The 2 and the x and the dx leave me with just a negative left over with that du. So oops, that dx should become a du. And we have a pi coming along for the ride. And then when x is 0, u is 0. When x is 1, u is negative 1. So then you just plug it in and evaluate that. And Bob is your uncle. So there you go. You can look at it for a second longer. Let's look at number 6. So same way, y equals 4x minus x squared. That's basically like an upside down parabola. It's going to shift it over a little bit, something like this. You get your y equals x function here. So now we're getting a little bit more interesting. So these intersect at 0, 0, right? And then they intersect at, what's the other value? I guess I'll have to sum them together. Put them together to find out the other intersecting value. So 4x minus x squared is equal to x. So we bring it over. So this would be 3, it looks like, because 3x minus x squared is equal to 0. X, 3 minus x equals 0. So yes, 0 and 3. To set up our integral, then we just do the integral from 0 to 3, the bounds of our region. In there, I'm still going to use a 2 pi x, and then a typical height is going to be, when I go up, I hit the 4x minus x squared, and when I go down, I hit the x. dx. Simplify it, spread it out. Robert is your uncle. All right. Let's look at number 7 here. Similarly, we're still going around that y-axis. Here, I'll draw the y-axis. We're going around here still. So the first one, y equals x squared, looks a little bit like this. This next one, it looks like it's been shifted a little bit. If it's helpful to draw this, you might say, well, y equals, we can pull out a 2x, right? And say we have then left in there, 3 minus x. So x equals 0 and x equals 3 are two of my points here, 0 and 3 for drawing this. It doesn't quite give me the bounds of integration because that's going to be just where I have this region enclosed. So to actually find my bounds of integration, it looks like 0 solves both of them, but I want to see where they actually cross. So to find those bounds of integration, we're going to set the y is equal, x squared is equal to 6x minus 2x squared. So these are different problems. When I solve this, I'm going to have, say, like 3x squared, bringing everything to the left, minus 6x equals 0, pull out a 3x. We have x minus 2 left over, so that would be 2. 0 and 2. Good, so setting up our bounds of integration is going to be dx because our rectangles would be vertical. X goes from 0 to 2 for that region that's enclosed. When I go up, I hit the green one, so the height here, when I go up, I'm going to hit 6x minus 2x squared, and we subtract off going down, I'm going to hit the x squared, and then remember formula is 2 pi r, or in this case 2 pi, the x value, because that's the distance from the center of the axis of rotation. You got to pause these videos if you want to spend time with them. All right. For these particular numbers, because we want to do it this way, I then gave you a problem 9 here. All right, so for problem 9, we're going to do the same thing, but we're going to have to sort of figure out which way we want to draw these things. We're going around the x-axis this time, right? And so for cylindrical shells, I need to draw my rectangles parallel to the axis of rotation. So that means all these problems where I'm going around the x-axis are going to be in terms of dy. All right, looking at number 9. We might, I guess we'll use the same axis. Let's sketch in here what we need. So this looks a little bit like this. There's two sides to this. We'll find out which side we actually care about. Looks like we're going to care about the y's being positive, so we're going to just draw this half of our function. So we have x equals 0, which is this axis. We have y equals 1 and y equals 3. So this is our region. Because we're using the shell method, I want to use dy. If we were using disk washer, I would use the other direction. In blue, then, I'm going to have a dy. The y values they've already given us go from 1 to 3. 2 pi, the distance from the axis of rotation to my stereotypical rectangle is just the height of that, just the y. So 2 pi r is 2 pi y. Now I need, what is this size, the horizontal size, the quote height maybe of that rectangle. And that would be the distance from the axis to this curve minus 0, because the other half is directly on that axis. So that would just be this curve, xy equals 1. Now really the distance there I'm looking for is that x distance, but I want it in terms of y, so that for a given y, I know what the x distance is, so 1 over y is what I'm plugging in there. And this works out really nicely because the y's cancel, eh? And so we end up just ending up with 1 to 3 of 2 pi dy, which is fascinating. When you solve that, you're going to have 2 pi times 2, so 4 pi. And this is in, this is a volume though, right? So they didn't give us units, but they'd be volume units. So if there were distances, now we're volume cubed. Fascinating. Don't want to go there. Oh, we got time to set up another one or two. Let's do this. Get a nice clear spot. All right, real time. Here we go. Same deal. Y equals square root of x. So that would look something like this. X equals 0. That's the y-axis. We're going around the x-axis. We got y equals 2. So for a stereotypical shape with the method of shells, it's going to be dy. Y is going to go from, it looks like the x0, 0, so it goes from 0 up to that y value of 2. 2 pi y is the radius of that rotation, and then the height of one of those things, you really want to be that that square root of x value. It's kind of what you're looking at, right? And we say, what is this x value though? How big is this? Well, for a given y, I want to plug it in. So I actually need to solve that and say this would be the given x value there is actually equal to the y value when then you square it, so y squared. Let's look then at number 11 here. Same idea. So these should get faster as you go along. So y equals 8, x equals 0, and then this part of the cube curve. Right, we're just going to sort of set it up. The y values are going to go from 0 to 8, right? We're going to be dy, like we said before, because of where we are rotating to get our volume. And then in there, we got 2 pi y, and the stereotypical height of one of these rectangles is going to be that value of, we'll solve, right? So y equals x cubed. You have to solve that for the cube root of y. So there you go. That's number 11. Do we have time for one more? Maybe not. This video is getting pretty tight. But can we rush? Same way, right? You'd say here you have a function. And you got your x equals 0, right? Always drawing those pictures is very helpful. X equals y squared minus y cubed. And so this is going to have, some shape that sort of wobbles through there, whatever it's going to be. You need to find out where you get your, we're out of time.